All right, so let's move on to chapter 10.2 and learn how to implement traits. Traits. See what they're talking about here. Traits, defining shared behavior. A trait tells the Rust compiler about functionality a particular type has and can share with other types. We can use traits to define shared behaviors in an abstract way. We can use trait bounds to specify that a generic can be any type that has certain behavior. Note, traits are similar to a feature often called interfaces in other languages, although with some differences. Okay? If you're familiar with interfaces, this is going to sound really familiar. Defining a trait. A type's behavior consists of the methods we can call in that type. Different types share the same behavior if we can call the same methods on all of those types. Trait definitions are a way to group method signatures together to define a set of behaviors necessary to accomplish some purpose. For example, let's say we have multiple structs that hold various kinds and amounts of text. A news article struct that holds a news story filled in a particular location, and a tweet that can hold at most 280 characters along with metadata that indicates whether it was a new tweet or retweet or a reply to another tweet. We can make a media aggregator library that can display summaries of data that might be stored in a news article or a tweet instance. To do this, we need a summary of each type, and we need to request that summary by calling a summarize method on an instance. Listing 10-12 shows the definition of a summary trait that expresses this behavior. I see. So to summarize what they're saying here, the scenario is we have two different structs, right? We have one that's a news article, deals with string, that has text in it, and we want to be able to summarize it. Over here, we have another type of struct called tweet. Works like Twitter, we have information here, has an X amount of characters, other things are related to it. However, more or less, we want to be able to summarize this and we want to be able to summarize this. So now we have defined a behavior called summarize. Both of these things need to have the function summarize on them. So we define a trait called summarize, and we give it a function definition. So public trait, so it's public, you can call it trait, just a body of a grouping of methods, or a grouping of functionality methods. And then we're saying this trait has a function called summarize, and it returns a string. Okay, so here we declare a trait using the trait keyword, bam, and then the trait's name, bam, summarize, in this case. Inside the curly brackets, we declare the method signatures that describe the behaviors of the types that implement this trait, which in this case is function summarize self string. And this is the behavior that we want to illustrate. Cool. Let me keep that in screen. After the method signature, instead of providing an implementation within curly brackets, we use a semicolon. So here you can see we have a semicolon, no implementation, just a semicolon. Each type implementing this trait must provide its own custom behavior for the body of the method. The compiler will enforce that any type that has the summary trait will have the method summarize defined with this signature exactly. So what they're saying is if you give a struct or enum this trait, the compiler will make sure that that struct or enum or wherever it is, it implements this function with this exact signature. To enforce that it adheres to this trait. A trait can have multiple methods on its body. The method signatures are listed one per line, and each line ends in a semicolon. Implementing a trait on a type. So now that we've defined the desired behavior using the summary trait, we can implement it on the types in our media aggregator. Listing 1013 shows an implementation of the summary trait on the news article struct that uses the headline. the author, and the location to create the return value of summarize. For the tweet struct, we define summarize as the username followed by the entire text of the tweet, assuming that the tweet content is already limited to 280 characters. For the tweet struct, we define summarize as the username followed by the entire text of the tweet, assuming that tweet content is already limited to 280 characters. Here's an example, and this is a library. Note that, library. So we have a public struct called news article, and we have public headline, which is string, public location, string, author, which is string, content, which is a string, all public so we can access them. We have the implementation of summary for the news article, which, as they described earlier, we just format a string, format, headline, by, author, and here's the location. Move on to tweet, which has a similar structure. Public tweet, public items within it. So username, content, reply, retweet, replies, boolean, retweet, boolean, cool. And then we have its own definition of summarize. What I did miss. We're implementing summary. This is the trait, and that trait was defined up here. So this is still the same file. Source libs, and then you can just import it and use it directly. I see. I guess technically speaking, because it's just Rust code, we can just write it out in one file just to make sure everything works. So let's do that real quick. So let's move this over, call in the editor, erase this stuff. I'll keep a main because I want to use it. They made everything public because it's a library and people are going to access the library. I don't have to make it public, but I will, just to follow that convention. So I'm defining a trait, pub trait, we're calling it summary. Alright, and then we have our function, summarize, which has access to self, and it's going to return a string. And because this is a trait, we define, or we write out the function signature and then end it with a semicolon. Right? Next, we have our structs, the things that are going to implement summary. So let's do our news article first. Struct news article, pub headline, it's going to be string, pub location, it's going to be string, pub author, it's going to be a string, pub content, it's going to be a string. And let's not implement summary just yet because I want to see what the error. No, it doesn't know it's implementing summary, so it's not going to have an error yet. I see. So let's implement it now. Implement summary, the trait name for news article. Oh, I spelled it wrong. Put that E there. So we're implementing this trait for news article. And how's the function? It's going to fill in for me? Nope, it is not. Okay. Self, same signature. String. That space there. Using the format macro. By our location, self add headline, self.author, self.location. And I guess it's being returned, so it has no semicolon at the end. Continue onward. Do for the tweet. Pub username, string, pub content, string, pub reply, boolean, pub retweet, boolean, implement summary for tweet, right? Summarize and self string. Now we have the body format, self username, self dot content, and technically speaking these are just methods, so I'll do it for one. Let's create a let tweet equal tweet username Crazcalm, content equals Rust stuff, reply false, retweet false. And these are not strings by themselves. I forgot how to cast it as strings. Come back to that. So print macro. Tweet dot summarize. I really did forget how to cast these as strings, because right now they're string slices, but they want strings. See what you say. Convert from string to string. Convert to string. That's how we go about doing it. Editor save the day. So to string. I just forgot the method. To string. And there's only 2 of those. Alright, so if we run this, we get our summary. We run this and we get our summarization of my tweet. Crazcalm, username, Rust stuff. Cool. So that basically works, and I expected it to work. Alright, so now let's change something to make sure this is working the way we expect it to. So technically speaking, if we remove, actually no, we should keep that one. We're actually using that one, right? But it said the compiler is going to enforce that these methods are created with the exact same signature. Let's change signature of one. It has a mismatch. Put a semicolon so it's not returned. And now the compiler should yell at us and see what error they gave us. This is the type in trait. This is what was here, and expected a string as the return. I see. So yeah, it is being enforced. That's kind of cool. Alright, so let's put that back and continue. I just wanted to make sure I did that right or understood it correctly. Alright, continuing onward. Implementing a trait on a type is similar to implementing regular methods. Pretty much, this looks like a regular method, except that the trait name is here. The difference is that after implement, we put the trait name that we want to implement, then use the for keyword. This is new too. Then use the for keyword and then specify the name of the type we want to implement the trait for. Within the implement block, we put the method signatures that the trait definition has defined. Instead of adding a semicolon after each signature, we use curly brackets and fill in the method body with the specific behavior that we want the methods of the trait to have for the particular type. So yeah, this is implementing summary with the name of the trait for the type, the struct that we want to implement for, or whatever we want to implement it for. And then within the body of the implementation block, we write all the function signatures that are within the trait, which this trait only has one. And at the end of this function signature, we put a code block and write the implementation of this method. Cool. After implementing the trait, we can call the methods on instances of news article and tweet in the same way we call regular methods, which I already did that. I was curious. I jumped ahead. My bad. And they have their example, which is much longer than mine. Then you use string from, and I use toString. Slight differences. This is a lot of text. Let me expand this. Expand. Note that because we define the summary trait and the news article and tweet types in the same library, lib.rs, in listing 1013, they are all in the same scope. Let's say that the lib.rs is for a crate we've called aggregator, and someone else wants to use our crate's functionality to implement the summary trait on a struct defined within their library scope. They would need to bring the trait into their scope first. They would do so by specifying use aggregator summary, which then would enable them to implement summary for their type. The summary trait would also need to be a public trait for another crate to implement it, which it is because we put the pub keyword before trait in listing 1012. So coming back up here, what they're saying is that if we were to put this into a crate and other people would like to use it, one, this trait has to be public, which it is because it has pub right there. And the way they would define it would be just like anything else for the most part. It's, going back to it, use aggregator, which is going to be the name of the crate, assumingly, summary, which is the name of the trait. And then you can use it in the code like we used it in ours. One restriction to note with trait implementations is that we can implement a trait on a type only if either the trait or the type is local to our crate. For example, we can implement standard library traits like display on a custom type like tweet as part of our aggregator crate functionality because the type tweet is local to our aggregator crate. We can also implement summary on vect in our aggregator crate because the trait summary is local to our aggregator crate. But we cannot implement external traits on external types. For example, we can't implement the display trait on vect within our aggregator crate because display and vect are defined in the standard library and aren't local to our aggregator. This restriction is part of a property of programs called coherence, and more specifically, the orphan rule, so named because the parent type is not present. This rule ensures that other people's code can't break your code and vice versa. Without the rule, two crates could implement the same trait for the same type and Rust wouldn't know which implementation to use. That was a little confusing. So in summary, what they're saying here is that if we want to implement a trait on an object or struct or enum, there's a condition that has to be met. Either the trait or the type has to be local to our crate. And they give an example. So display, on implementing display for type tweet in our aggregator crate. We can do that because we own tweet. We created it. So the second example is implementing summary on a vector in our aggregator crate. We don't own vector. That's part of the standard library. But we own summary, which is the trait. And because we own summary, we fall into this category and we can apply it. However, in the third example, we have this implement display trait on a vector within our crate. So the trait display, we don't own that. Vector, we don't own that. And because we don't own either of those things, we can't implement it. It's a part of their orphan rule. And it does make sense. So cool, moving onward. Default implementations. Sometimes it is useful to have a default behavior for some or all of the methods in a trait instead of requiring implementations for all methods on every type. Then as we implement the trait on a particular type, we can keep or override each method's default behavior. So let's see, in listing 10-14 shows how to specify a default string for the summarized method of the summary trait. Instead of defining the method signature, listing 10-14 shows how to specify a default string for the summarized method of the summary trait, instead of only defining the method signature, as we did in listing 10-2. So in summary, what they're saying here, summary being ironic because it's summarized and the trait is summary, but what they're saying here is that when you define a trait, you have the option of giving it default behavior. And one reason you may want to do that is, let's say you have 4 or 5 different structs, right? And out of these 4 or 5 different structs, most of them are going to do the same exact functionality. Maybe one of them is different. So when you define this trait, you make them all implement this trait, whatever this trait is. You can have them use the default functionality, at least for those 4, and then for the 5th one, you can override it with that special case. And that just saves you a lot of writing. Whereas if we went by what they did earlier, where they just wrote out the function definition here, and they had no body to it, we would then still have to write duplicate code for each one of those 4 structs that have the same exact logic. So this is saving us time. It's useful. I'll like it eventually, but it's still sinking in. To use a default implementation to summarize instances of news article, instead of defining a custom implementation, we specify an empty implementation block with implement summary for news article. So this is what you use this is what you write if you want to use the default implementation, which is this thing. And they do that here. So we have, I'll read this first. Even though we're no longer defining the summarized method on news articles directly, we've provided a default implementation and specified that news article implements the summary trait. As a result, we can still call the summarized method on an instance of news article like this. So this is given that we have already defined news article and we've written out this line in our code which implements summary. That means we can still call it, and then when we call summary here, given that it's not defined explicitly for news article, not overwritten, we'll use the default behavior, which is this. And this code should print out news article, new news article available, read more, ... Yeah. Cool. Creating a default implementation for summarize doesn't require us to change anything about the implementation of summary on tweet in listing 10.13. The reason is that the syntax for overriding a default implementation is the same as the syntax for implementing a trait method that doesn't have a default implementation. So what they're saying here is that even though we already wrote a implementation for summarize on our tweet struct, that does not have to change. We just wrote a default implementation for summarize on the trait itself, but that's being overwritten. And having this in place does not affect our tweet instance and that version of summarize. Moving onward, they continue by saying, default implementations can call other methods in the same trait, even if those other methods don't have a default implementation. In this way, a trait can provide a lot of useful functionality and only require implementors to specify a small part of it. For example, we could define the summary trait to have a summarize author method whose implementation is required, and then define a summarize method that has a default implementation that calls the summarize author method. So what they're saying here is that in a trait, you can have multiple methods, right? This is something we already know. But within these methods, you can call each other. So their example is having a summarize author method, right? Where they do not give a default implementation. But then in summarize, they call the summarize author method and use it here. Okay? To use this version of summary, we only need to define summarize author when we implement the trait on a type. So just so this sits well with me, let's write this out. Move that over, bring our editor back up. So here, let's change size. We can modify our summary so it fits theirs. Well, first let's add the other method. Function summarize underscore author has access to self, returns a string, has no default implementation. Summary, on the other hand, does. Format string, read more from dot dot dot, and leave that the same. Self dot summarize author. We can call that directly. Now this is lighting up red because we have not fully implemented summary. Function not, oh, for news article, I'll do it for tweet. Tweet I can remove. This is going to be summarize author, self, string, and this is just going to return something. Self dot author. Did I spell that correctly? Summarize author, summarize, I did not. Author. Do I not? No, I have access to that. It can't be moved. Since it has to be a string, I'm gonna have to clone it because I don't want to move it. That makes sense. But I am returning something. Okay, and then for tweet, I can do the same thing. Function summarize author self string. This one does have an implementation, and it's going to return self dot. Do I have an author? No, I just have a username. Username dot clone. And just to test this out, let's remove this version of summary. Control X, cut it out, and let's run this to see what it does. Got an error. 21, line 21. This thing. Summarize string. Expected string found nothing. Oh, that doesn't return anything because earlier I put a semicolon after one of them. That's why it doesn't return anything. That was me. That was all me. So now we see that we're running the tweet, right? Let's go back down. We have our tweet, we have the information filled in, right? And we do summarize. Summarize, because our tweet doesn't override the default implementation of summarize. It uses the default. The default says, what does the default say? Read more from, and then has the summarize author. So this says read more from Crazcalm, which is the summarize author, which is defined in our implementation of summary on tweet. Our implementation of summary for tweet. There we go. That's the correct phrasing, I think. Cool, so that makes sense. So let's get back to here. To use this version of summary, we only need to define summarize author when we implement the trait on a type, which we did. They did at. I didn't, but I guess that makes sense. Ooh, they will use format, and format returned a string. I see. In that case, you don't have to clone it, because format will. That's good to know. Format. And then do at comma I could probably do the same thing for the first one, granted that I wanted to format it. So this should be almost the same. This is not the same. This is now yelling at me. And it's yelling at me because we imported something on accident. That is annoying. But outside of that, bam, got the at. Cool. So that's what they wrote there. We mimic them. After we define summarize author, we can call summarize on instances of the tweet struct, and the default implementation of summarize will call the definition of summarize author that we've provided. Because we've implemented summarize author, the summary trait has given us the behavior of the summarize method without requiring us to write any more code. Oh, so what they have here is they have their version of tweet, which I guess I could have made mine look a little cleaner like they did, put everything on new lines. Yeah, now everything's on new lines. And they call tweet.summarize and use the default behavior. And yeah, that's what we did. Cool. Note that this isn't possible to call the default implementation from an overriding implementation of the same method. Cool. So what they're saying here is that if you override the method, so like say here, right? I made a function called summarize and has the same signature because I'm overriding it. Self string. When I go to write the function block, those are M's. When I go to write the function block, there is no way that I can, within the overriding of summarize, call the default, which is this up here, version of this method. The reason they had to explicitly state this in the book is because inheritance, things that use in other languages like Python, with classes and whatnot, can do this. You're expected to do this. You have that option. I guess you can also do it in languages like Go with embedding, but that's beside the point. The point is that in Rust, in this method, summarize within my tweet, I cannot call the default implementation of summarize that is defined within the trait. That is good to know. And let me remove this. Moving onward.